All right, so then I would say, let's start. Welcome to this webinar, MBSE meets co-simulation. We have this webinar here together with a partner from AVL. Schulze Hedner is also here. Welcome. The reason for this webinar is that we are actually asked by customers several times, how do we actually connect the systems engineering with co-simulation or simulation and test beds and this kind of things. And so we decided to investigate in this topic and analyze a bit how do we merge model-based systems engineering and system simulation. My name is Christian Bremer. I'm Managing Director at Two Pillars. And Joe, please, maybe you want to say 2 or 3 words to your person.
Yeah, thank you, Christian. Thank you for the invitation, and also hello, everyone. I'm from AVL, and AVL is the largest independent company for development, simulation, and testing in the automotive industry, and also in other sectors. And I'm chief engineer there, focusing on digital process innovation. So I help our customers introducing model-based development and virtualization, for example. Thank you.
All right, so let's have a look at the agenda for today. We will start with an introduction, MBSE and system simulation. What are our thoughts? What are our concepts? Then secondly, the main part of this webinar shall be really a demonstration. We will go into the tools, into Qavis and model.CONNECT and show how does this process and the integration work. And third, then we will close this meeting with a summary and outlook about the next steps. So, Joe, maybe first give us an overview on motivation, maybe from your point of view.
Yeah, thank you. Very short motivation here. When we look at the vehicle development process or any product development process, we typically have this product structure driven level here, this upper level, what we see here. And of course, that's the leading process. We have the CAD, they are the product lifecycle, product data management. Also, systems engineering, model-based systems engineering would be placed vehicle software. And of course, that's a very important process because out of this, we know how to build the product. And of course, we use this to build a prototype and validate if the product fulfills the requirements. But of course, we all know that's very late in the process. And of course, this is a huge challenge. And that's why we introduced this functional representation, where we get a view now on the product, where we can validate the product now in all phases of the development, and especially in very early phases. And one might say, yeah, but that's simulation. No, it's not just simulation. It's really having this view on the product. And that's why we're talking here about virtual prototypes and mixed prototypes if we have simulation on the test bed, for example. And so with this approach, in the end, we end up with this continuous validation in the development process. And these two processes are very separated. And that's why we are sitting together here. We came up with an idea here to support this interaction of these two processes. Christian.
Yes, so what is the general thinking? When we now place these two worlds, Qavis and model.CONNECT, where are the connections actually? The first point is maybe the obvious one, the system architecture. We in Qavis, we have a system structure, we have a description of how does the system work, kind of, and obviously we need to take this model and transform it into a system simulation, or in our case, we call it now here a co-simulation architecture, where we have a simulation blocks maybe for each of these components. You see here on the left side as Qavis now an environment model. For those of you who are already familiar with Qavis might see it very easily, but in any case, also when you saw other systems engineering tools, these diagrams will always look pretty much the same. And this idea, of course, to say, okay, we have a model transformation is not completely new. However, looking at the practical process, we saw that, well, the model itself, the simulation model itself, does not fulfill a purpose if there is not a question in the first place. We need to have a question or a test case that we need to answer in order to create our system model in the system simulation. So the second thing is then that we say on the Qavis side, we have the dependencies from the requirements to the test cases. And this is the knowledge we have to also bring into this consideration. And third point, we also have a dimension of planning these test activities. Also, this is a systems engineering task at the end of the day. And it means then that we also have to integrate this into this loop, yeah, of the system simulation by having an automated execution of this co-simulation orders. And by this, we close the loop, the systems engineering loop, where we say, okay, we have the architecting part, the system simulation, and then the feedback. This is the idea.
Okay. And let me just tell us a little bit about model.CONNECT or the co-simulation here. Yes, we love co-simulation. We think that's the proper technology here, because co-simulation takes now over this idea that we get out of the system architecture, out of the model-based systems engineering approach. We can use this modular concept, bringing together components here, component simulations, build up then in the end what we call then this virtual prototype. And it's a very flexible approach, so we can connect here different tools that are available on the market that typically used in your companies. And so it's up to 30 different tools that we are supporting here, but clearly we're also supporting here the standards, and we're also driving and pushing the standards like FMI, functional mockup interface, distributed co-simulation protocol, DCP, or the system structure and parameterization, SSP. We will also use this later in the demo, you will see this. And what we also can do with our co-simulation is we can even bring the test beds into the simulation. So we can connect our co-simulation to hard real-time systems and have methods and technology to do this. And yes, now this model.CONNECT or the co-simulation, that's what we are using now in the demonstration later on. And Christian, maybe you can explain now what we want to show.
Yeah. So on this slide here, we will build up now this traceability concept. Which is the basis for our linking of the software. And this traceability starts typically, of course, with the requirements. So we will have Qavis with requirements in the first place. Here as an example now, this requirement of a consumption. So we will take a vehicle now and say we have a requirement as a consumption. We want to test this requirement at the end of the day. So we will connect these requirements now to two elements or model elements. It's first, of course, the test case. So we have to make sure that for each requirement, there is a test case where we say we can validate this requirement. This is like a general principle. We should test each and every requirement. And secondly, we will have a link from the requirement to the actual realization of this requirement. In our case now, the vehicle. And we describe this vehicle here typically with such an system architecture, maybe system structure. Yeah. Sometimes we hear words like mechatronic sketch. They describe that we describe here how do these modules that belong to the vehicle, how do they work with each other? What are the dependencies? And at the end of the day, how is the architecture described? So this is kind of the core traceability that we have as a system description. Of course, you will find in system architecture much more data. You will find functions, you will find use cases, features, and so on. It's very clear. This is, of course, also part of the system architecture. But for our consideration right now, these three data elements are the key elements. And this is what we will focus now in the demonstration on. And then what we have to do is then to realize these test cases. So we take the test case, the WLTP case in this scenario now, and we bring it really into a schedule. At the end of the day, we need to schedule the test execution in a project plan, in this case in a DVP, in a design validation plan, and bring it into an order to make them, to bring it into a plan and make sure that they're executed. So this is the project planning part then. And then at that point, model.CONNECT comes into place. It will take the system description. So it will analyze how does the system actually work, or how is the architecture defined, will transform this into a co-simulation model, and then take the task, the WLTP test case task, realize it, and creates a result. This is in this case then the energy consumption, and this data will be linked first to the test case, of course, but also to the actual task that has been executed. So this follows also the very general principle that we define a test case and the test task, first of all, even independent from where and how this test is actually executed. Yeah? This is like the second step then. So we bring back the result then in the test case and in the task. So this is the traceability concept. And now I would go into the tool and demonstrate to you how it will work. So you see now Qavis, and you will find here in this tree again this basic tree that we saw before. We have here our requirements, we have our test cases, we have our entities. I want to show to you very briefly the content just once again. So here we have this requirement that I just mentioned, the WLTP consumption. It is linked to the vehicle and also to the test cases. As I said, there will be more information in the whole system model for sure. There will be a lot of functions and use cases and so on. We intentionally focus now really with our content here on this information that we need. And build views. We will always build views on the model, of course. These requirements typically will be described also in a table where we have more information. Maybe we will find in such a table also a unit and other information. We here now have this requirement, first of all, just as like a bubble, right? Then we have our test case, WLTP in this case. Also here we will have more information, of course, linked. And we have then the link to the vehicle. Yeah, here in this case, yeah, we have the vehicle, we have these modules inside the vehicle. And here I want to show to you how this description is actually built up. So we have the VTMS, we have the engine, we have the driver, we have the driveline. These are these elements that we saw before also in the tree, but we have of course described the architecture. This will be taken then again by the model.CONNECT tool as a next step. So what we want to do now is we want to confirm the status of the requirements. And this is done here with this table. So this table is generated automatically. We'll see here our requirements. As again, this WLTP requirement, it has a certain value to be fulfilled. Right now, the status is negative. We have our test case allocated, and then we have the execution. Right now, we have here one experience we set up for test purposes is 0, and we have defined here the task. This task comes from the schedule chart. Also, this is a part of Qavis now where we schedule the activities and especially, of course, schedule the test tasks. So, and in this case now, again, we focused really on the information we want to see. We have the DVP here, and we have here our task. Right now, this simulation task here has not been started. So I will do this now. I will start the task and set the status here to ongoing. Okay. And by this, I will trigger now the server to check for information on the server. The model.CONNECT will check the Qavis server and asks for tasks that have not been completed yet. So it will see, okay, there is a task that we need to perform, and it will generate the model and realize then this simulation, execute the simulation and create a result. So I have to update. Now it's there.
Now
okay.
it's
So you see now the task has been completed. So there must be a new result, and I will go back to my requirement status. And I see here now there's a result 5.2 coming from this date today. So what I have to do now as a last step, maybe in Aquabis, to start editing and save one time to apply my business logic. And then you will see, okay, the test status of this requirement has been set to green, positively tested, so it is confirmed. So by this, we will get back the result of the test case. This is also visible here in this traceability tree. But for now, this should serve maybe as a first overview about what's happening. We will have the entities, the requirements, the test cases, and get back the test result with the simulation data or the simulation result, and can process this and then set the requirement to true or to test it. Okay, so this is the Aquabis part, and I will go back to the presentation and hand over then to Joe. Maybe you can give us some insights into what's happening in the Model.CONNECT world.
Sure. And finally, it worked. So we can now show what we actually did there. And Christian already mentioned this a little bit. So now this co-simulation workflow got a little bigger. So we get this information and there is a new task to perform. We download, we get the system architecture. And what are we doing with it is that we convert it into SSP. This is now this standard that I was referring to already before. And this one now describes the co-simulation in a standardized way. And this one we import into model.CONNECT, can then perform the co-simulation, apply post-processing. So we do not report back now the time charts, but we calculate using a Python script here, a KPI, key performance indicator, and this one we report back to Qavis. But we also store this KPI on our side with necessary traces, so which models were used, which test definition, for example, was used. And so that we always can repeat the task and have full traceability. And additionally, as you have seen, we report back also a unique ID, a date and time, and we set this date to finish. And let me also share my screen, just give you a very short insight what is happening now in the background there. So this SSP, what we are generating, you should see my now my screen. This SSP is basically a zip container. And if you unzip it, you have some description inside, and this description is a XML file. We don't walk through this now in detail, but this is now the description of the co-simulation. And then when we go to model.CONNECT, so what you can see now is the model.CONNECT user interface, and we can import now this SSP, and takes a short time. And then you will see we have the full co-simulation configuration in here. Of course, there's a lot of additional information, but all these blocks here, they contain now the models, in this case, really a functional mockup unit. Normally, our co-simulation projects look like this, a little better organized. But in this situation, of course, no one actually is interested in the user interface, because in the end, all this task is run completely automatically, as you have seen before in the demonstration from Christian. We just wanted to show you what is actually going on there in the background. And also maybe as a comment, we are not limited here to functional mockup units. We can use any kind of simulation tools that are maybe then stored in model databases. We will come to this later, and so on. So we are very open here. Good. And that was the information on the demonstration. And Christian, you have a little more also in the direction of libraries. I think we have a little time left.
Yeah. So what we show to you right now is really this very basic overview and the concrete use case. How would you work with it? Behind there is of course, a more complex concept also, because as you can imagine, you don't want to create an architecture from a new system from scratch and also derive all this simulation data from scratch, but you will work based on libraries. And this is what is described here. And I can only, again, in this webinar, discuss it very briefly, but still to give you this information, there is this concept that we have a library for the system architecture, where we see maybe the driveline and the engine in this case, they are defined. They have ports and so interfaces. Yeah, this is all defined. They consist of parameters, maybe the curb weight or other kind of parameters. And they are also linked to simulation elements that can be put together later on into a simulation. This is part of the library. And then if you go and set up a project or start a project, then you take these model elements, of course, the driveline and the engine, you bring it into a specific context by linking it to each other using the interfaces. You will then, secondly, also define your parameters. So we will set the parameters with certain values. This all needs to be also managed then later on, because it's a big question with which kind of parameter set you actually did a calculation or simulation at the end of the day. So this is just another step. And then a third step, based on this, the actual co-simulation will be generated, again referring to the library concept where we have this linking. And this is also necessary, of course, to then derive the simulation model in a way that it really fits together and can be executed in a way that it answers at the end of the day the test case. Yeah, so again, brief summary, brief explanation of this library context. There's more information and structure behind, as we could show in this very brief webinar. Yeah, and this brings us already now to the conclusion. Joe, maybe you want to summarize the webinar.
Yes. What we showed you was really a solution now for the problem that I have shown you in the beginning, this challenge of the separation of the process or product structure driven process with this functional representation. And we think it's very relevant that we use here the system architecture as central element that holds all this information together. And out of this, we derive the co-simulation configuration now. So we really link the co-simulation very closely to the system architecture, meaning then to the complete process level there. And with this, we can now really do a continuous validation. We can even use this configuration then to go to the test bed. We can replace the virtual e-motor, for example, by a real e-motor operated on an e-motor test bed. And so that's a very important linkage methodology that we are using here, linking methodology. But furthermore, what we have shown to you was that this planning aspect is very relevant, that also this definition of the test cases, they are coming out of the requirements, and that we again here establish this link here via the system architecture, via the MBSE description that we have here. And the system that we have shown to you, this demonstrator, we are using REST APIs here. So this we can actually start or could start implementing this system on your side if you're interested right away. And as also Christian mentioned, this library concept, of course, is something very important that increases then the usability of the overall system drastically, because we have these two worlds and different sets of libraries or databases, however we want to call it. On our side, for example, the models then and parameters and the virtual prototypes and results. So there are many things there. And on the Qavis side, we have the system architecture, the requirements, the validation plan. And of course, it will then be great when we can synchronize these libraries. So when we recognize there's a new component on the system architecture, we can validate, is there a model available for this? If not, we can order a model or can check the model upfront if it fulfills the specification and so on. So again, to support here the traceability in the process. Yes, so very short introduction of the topic, but if you're interested in this presented concept, please contact us, contact Christian, contact myself, I contact Data Insight. We would be very interested to work together on this topic with you.
All right, thank you, Joe, for the summary, and thank you to the audience, first of all, for participating. Thank you for your attention. And thank you very much, Joe, for joining the webinar and this interesting project that we have and that is still ongoing. If you have questions, you are, of course, able to post it now in the chat. I also read in the chat already that there might be some connection problems or problems with the visualization of the demo. I'm currently not completely aware of what happened, so we will definitely check the recording after the webinar and make sure that you will receive the record in a way that it is definitely readable. So if we missed something in the record, they will record again. I don't know. We will check it and make sure that you will get the demonstration. But if there are any questions, then please go ahead, post it in the chat. Otherwise, I would say thank you very much again. And yeah, see you next time. Yeah, one question. What is SSP? Joe, this goes maybe to you.
SSP is a standard that is also hosted by the Modelico Association. It's called System Structure and Parameterization. And when we think of FMI, Functional Mockup Interface, this describes a simulation model as a black box, just inputs, outputs, and some additional information. But when you want to connect now several FMUs, several of these models together, this is specified then by SSP with some additional information also on parameters, for example. And this is really a very important upcoming standard. Not so many tools are supporting this at the moment. So Model.CONNECT was the first one actually. And yeah, that's SSP.
Next question. Where in the process roles and process steps can the solution be used? Joe.
Should I start maybe? Yeah.
Yeah.
So from the development process side, maybe. So we definitely have two sides here. Definitely the project management level. They want to have immediate feedback, continuous feedback. This is one level there. Also the development of the system architecture. So also on this level, continuously validate what you're developing there. But also on the other hand, simulation departments, simulation engineers, they need to have the co-simulation, the virtual prototypes ready. And again, here with this, we guarantee, with the solution, we guarantee that the configuration that they are getting are the proper one. And so many different roles, people, groups are using or will use this connection that we are establishing here.
This is an interesting and good point that you make, because I think what also kind of turned out is that systems engineering is not only a task of system architecture in the first place and requirements analysis, which is often associated with systems engineering activities, but it's at the same time also the test and validation process on the system level. Yeah, so like left side and right side of the V model, this both are systems engineering activities. Then when we look from the Qavis perspective, of course, the systems engineer is the typical user, but his task is to make sure that the requirement is tested. So he has to also make sure that the tester, the person who builds up the simulation model, he also understands what should be tested, what is the situation, what is the system that he has to test, how does it look like, and this kind of things. So in that sense, clearly, of course, it's the systems engineer, it's the system test engineer, and all these processes that work with this information along the development process are user of this information.
Exactly.
All right, yeah. I think for the moment there are no more questions. So then I would say we close the meeting today. Thank you again for your attention. please reach out to us for more information. And yeah, I wish you a nice day.
Thank you also from my side. Thank you, Christian, for inviting us.
Thank you for
Bye-bye.
participating. Bye.